welcome to LearnCity. In today's class, we'll be talking on graphical solution of linear and quadratic equation. I'll be solving an example of that using a scale of 1 centimeter for 1 unit of the x-axis and 1 centimeter for 5 units on the y-axis. Draw a graph of 2x squared minus 2x minus 1 in the interval of minus 5 to 5. Using that same scale axis, draw the graph of 2x minus 3y plus 5 equals to 0. Then use the graph to solve the simultaneous equation of the two equations. Now, we first find table for 2x minus 3y plus 5. Now, we have to look for our y. So, we have 2x minus 3y is equals to minus 5. And we have minus 3y to be minus 5 minus 2x. And we have y to be minus 5 minus 2x over minus 3. So this x can cut it, this minus can cut each other. Then we have y to be 5 plus 2x over 3. Now, if we draw the table of x and y, we just draw for the minus 1. So we draw from minus 1, 2, and 5 to avoid being prolonging our table. But for the next one, we draw from minus 5 to 5. So where x is minus 1, we have it to be 1. 2 times minus 1 is minus 2. Then that will be 5 minus 2, which is 3. 3 over 3, which is 1. When x is 2, we have it to be 3. And when x is 5, we have it to be 5. Now, for the equation which says 2x squared minus 2x minus 1. So we have 2x, so automatically this is our y. Now, for our table to minus 5 to 5. So we have x, we have y. Minus 5, minus 4, minus 3, minus 2, minus 1. 0, 1, 2, 3, 4, and 5. Now, where x is minus 5, if we solve for minus 5, when we solve it, we have it to be 59. Where x is minus 4, we have it to be 39. Where x is minus 3, we have it to be 23. Where x is minus 2, we have it to be 11. Where x is minus 1, we have it to be 3. Where x is 1, we have it to be minus 1. Where x is 0, we have it to be minus 1. Where x is 1, we have it to be minus 1. Where x is 2, we have it to be 3. Where x is 3, we have it to be 11. Where x is 4, we have it to be 23. And where x is 5, we have it to be 39. Now, we'll draw our graph. So, for the y-axis, we have our x number to be 59. So, first of all, 59. Now, how do we do it? We can basically do it as 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, and 60. And for our minus, we have the least to be minus 1. One, 2, 3, 4, 5, 6. Now, for the first one, where x is minus 1, 2, and 5, we have 1, 3, and 5. Minus 1, we have it to be at 1. Where x is 2, we have it to be 3. And where x is 5, we have it to be 5. Now, for the second one, where x is minus 5, we have it to be 59. Where x is minus 4, we have it to be 39. Where x is minus 3, we have it to be 23. And where x is minus 2, we have it to be 11. Where x is minus 1, we have it to be at 3. And where x is 0, we have it to be minus 1. Where x is 1, we have it to be minus 1 as well. Where x is 2, we have it to be 3. Where x is 3, we have it to be 11. Where x is 4, we have it to be 23. And where x is 5, we have it to be 39. So, we draw. Now, use the graph to solve the simultaneous equation of these two. Now, the required solution will be where the straight line meets the curve on the x coordinate. Now, on the x coordinate, where do we have it? On the x coordinate, we have it to be minus 0.7 around this part. Will be around minus 0.7, and around this part we have it to be around 2. So here our answer will be x is equals to 2, or x equals to minus 0.7. X is 2 or x equals to minus 0.7. And this brings us to the end of our class on graphical solutions of linear equations. And in our next class, we do one for quadratic equations. So I'll be seeing you in the next class.